Okay, in this video, we will answer several problems on what exactly are we gonna solve? It's kind of stupid, but um, I know how to solve it, but I just can't remember the topic right now. Um, it's called HLDE. I just can't remember the entire name. Homogeneous. Wait. Homogeneous linear differential equations. There you go. So in these kinds of questions, we can solve it in two ways now. By something called MUC, that is by the method of undetermined coefficients, and the second method is called VOP, or variation of parameters. I'll break it to you already. You can use VOP for all kinds of questions. The only catch is the solution will always be long. If you solve by method of undetermined coefficients, in certain problems where you don't really need to perform VOP, then that actually saves you time, especially when you're taking an exam. Okay? So let's get to solving immediately. What do I want to solve? Give me some time. I'll just look for questions. There you go. So let's go through MUC first. Usually, we don't have to use VOP whenever we encounter problems wherein the right-hand side is shown to be any of the following now. I'll write it in a while. Okay, so you can use MUC. You don't have to use VOP if the right-hand side of your function has exponential. So for example, e raised to ax, or you have polynomials, x raised to n. You have only sines and cosines, no? Or finite sums or products of those. If ever you see anything that isn't any of these, then that's a sign that you have to actually solve using VOP, the longer method. And it's more complicated because aside from differentiation, you also have to apply integration. In MUC, you have to apply differentiation only. So although both solutions are long, normally, it's much more complicated if you use VOP. And if you don't have to, which is something that you have to know in the exam, ideally, basically it's easy to make mistakes if you use variation of parameters, no? Unless you're really careful with your algebra and you are ready to encounter monster level integrals, no? Okay, so let's answer a few questions already. Let's obtain the general solution of d squared plus 3d plus 2, and then y equal to 12x squared. Let's have this problem. First thing we need to do is we equate the left-hand side as as 0, no? So in the right-hand side, you will write 0, and you just copy the exact same thing. You can rewrite this, whatever is here in the left-hand side, as m squared plus 3m plus 2. Then you disregard the y. So this is, they're basically the same. And if you want to write it in terms of y, yeah, I think this is how you do it. Let me just confirm using my notes. My bad. So this one is gonna be interpreted as, as y prime, no? 3D y. This one is 2y. Okay, so after that, let's already write this, no? So we're gonna write this exact same thing, equate it to whatever we have in the first place, which is 12x squared. We're gonna need that for later. For now, let's use this, the one with the m. Identify the roots of the equation. So we can factor, no? And then m is equal to -2 and -1. These are the roots for y sub c. Later on, we're going to encounter something called y is equal to y sub c plus y sub p. This is the format for our particular solution. No? What we're looking for right now, this entire process, is looking for y sub c. And we have to look for the roots first, which are these. So, we write c1, the first constant, and then e raised to -2x. This is the -2. Okay? And then plus second constant, e raised to -x. Okay, so that's basically it for this part. Let's now write r sub x, r of x, and then equal to whatever is in the right hand side originally, which is 12x squared. Then we look for roots. So from here, you just have to look at the degree of the variable. No? There's a table that you have to know, or like a list of rules. If ever you see, for example, just 12 as your r of x, it's a constant, no? And basically, the roots for that is just a single zero. What if you have 12x? You have two roots of 0. Right now, we have 12x squared, so I think you can already see the pattern, no? 12x squared, the roots will be 3 zeros. So let's do exactly that. We have 3 roots for r of x. Now let's write our y sub p. We base what our y sub p looks like according to the right hand side of our given, no? So 12x squared, that's gonna be a x raised to 2 plus bx plus c. If ever, for example, we are given instead 12x, 12x plus b will suffice. If we're given just 12, I think it's ax. We'll see. Sorry. We'll be answering quite a lot of questions tonight. Well, not really tonight for most of you, or several of you. Okay, so y sub p is this. We have to differentiate. This is the part where we differentiate, no? So we're gonna treat a, b, c as constants when we apply MUC, no? Method of undetermined coefficients. Later on, in variation of parameters, the same a, b, and c, or even d, if for really long problems, you'll have d. They will be treated not as constants, rather variables, no? So that's actually the reason why there is integration in VOP, because eventually you will see you will see a prime, b prime, c prime. You have to integrate each one. So that's what makes the solution really complicated. But the process is very similar, fortunately. So 2ax plus b. Okay, so that's the first derivative. Second derivative, how many times do we have to derive? It depends on the highest degree of your given. Right now, it's d raised to 2, no? Or y double prime. Or m raised to 2. So 2a. Okay, so that's good. That's good enough. Onto second derivative only, and let's assemble now our y sub p. Oh wait, sorry. What I mentioned earlier, we need to write this one. No? This is actually the part where we need it already. So we just substitute. This is this basically. The y prime here is this one. No? The only difference is this one, no? The sub p, but it's essentially the same as this. So don't get it confused. So 2a plus 3 times 2ax plus b. We're gonna distribute later. Sorry. Plus 2 and then y. Y is ax squared plus bx plus c equal to 12x. Simplify. In questions like these, it's mostly algebra, no? So you have to be really good with your algebra. If you're good with your algebra, you're gonna enjoy this lesson in differential equations. Because most of it is just algebra. What I'm teaching you, the extra methods that are pretty new to you, you'll eventually master them. The heaviest part here is really just the algebra. Okay, so I think this is it. We cannot further simplify anything else. What we do now is equate the coefficients. For example, we have the ones that have x squared. So its coefficient, 2a in the left side. The coefficient here is 12 in the right side. So you can look for a, b, and c. So a is equal to 6. Next, how about the ones with x? Okay. 6a plus 2b is equal to 0. Substitute whatever 6 is, and then transpose 2b to the left, to the right side. Solve for b, 36, negative 18. And then for c, the ones without an x, just purely constants. 2a plus 3b plus 2c equal to 0. So there's a pattern, no? I keep equating the right-hand side to 0 if there is no corresponding value that has the same variable, no? For example, here, these have x, no? At the right side, there's no term that has x, so we just put 0. Simple as that. Okay, b is negative 18, negatives 2c, c is equal to 12, 18, 9, 18, 27, 54. 12 minus 54, negative 42, negative 24, 24, positive. Wait. 12 minus 9, 18, 27, 54 divided by negative 2. 42, 21. That's supposed to be 21. Okay. So after finding a, b, and c, let us now substitute back to our equation yp. 6x squared minus 18x plus 21. Okay, after that, so that's our yp. Let's now compile. So going back to this, y is equal to, what's our yc? You just copy paste, no? There, and then the information in yp, you just add. So that's it. That's it for this problem. Let's find a difficult problem. Let's try something really spicy. Number 15. Are you ready? I mean, you're just supposed to follow the same technique. I hope I can still recall. It's been a few days since I've studied this topic. It's only been the most recent that I've studied is VOP. So being familiar with VOP, it's not gonna be that hard to recall whatever I learned in MUC. And I answered all 15 questions for this part, the part where you study MUC. Okay, so let's convert. You can also express this as y prime 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 minus y prime prime minus 4 prime minus 4. Here you go. And then, okay. So next, you can also convert this as like this. Okay. Just equate it to 0 at this point. So how can we factor? Or like basically find the roots? Let's try this approach. This looks easier. Okay, m squared minus 4, m minus 1 equal to 0. Is my voice... Okay. And then m minus 2, m plus 2, m minus 1. We have 3 roots. M is equal to 2, negative 2, positive 1. And then let's input their corresponding... let's create their terms in the YC. Y sub C. C1, E. Let's make a term for this first, then the 1. Only for uniformity, but the order doesn't really matter. At this point, it's just personal preference. Okay, next is positive 2. Constant 3, e raised to negative 2x. Okay, we're done in that part. Let's now... what do we do next? Right, r of x. R of x equated with the right-hand side. And then find the roots. Here, the root is 0, 0. Here, the root is just 0 because it's only a constant. Here, this is interesting. I think the root is negative 1. Yeah, I think it is negative 1. Hold up. My bad. Early in the solution, it's already wrong. This is supposed to be plus. Ah. Sorry. I didn't copy the problem correctly. That's supposed to be positive. Sorry. Minor mistake, although it can be catastrophic. So this is positive, this is supposed to be negative. So negative x. Okay? Okay, so the roots that we identified here are correct. Let's now create the y sub p. So we have an ax plus b plus c e raised to negative x. just get some approval if we can proceed. Okay, so this is our initial guess. It's not hurting anyone in any of the terms. It doesn't overlap basically. For example, right now we have a constant b. If you also have a constant in yc, regardless of what it is, you have to update your yp. The only way, fortunately, so it's easier to remember, you just have to multiply everything by x. But right now, that's not the case, so we don't multiply by x. Okay, so that's it. Y sub p is equal to, let's now derive. Highest degree is 3, no? So third derivative. Okay, that's it. And then, what do we do now? By third derivative, recall exactly this one. No? Let me rewrite it again. Y triple prime plus y prime prime minus 4 prime minus 4y is equal to 8x plus 8 plus 6e raised to negative x. Substitute now. So all of them now. This is gonna be long. Negative ce raised to negative x plus ce raised to negative x minus 4 okay. Simplify. Yeah, these will cancel. So they will cancel, no? What I highlighted. And then we equate. wonder what's supposed to happen next. We should be able to find C as well. Ah, so you see, I just lectured you earlier about conflicting values. We actually did have a conflicting value. So as early as this part, we have to multiply by x. My bad. Derive. Okay. And then second derivative. Okay. So it's much more complicated, no? This is our y triple prime, y double prime, y prime, and yp, ry. Okay, so just copy paste. This is y prime. Oh yeah, by the way. So that's gonna be minus 4 and then the y prime. Same thing for the y. Minus 4 y. What's the other side? Equal to 8x plus 8 plus 6 raised to negative x. We need to simplify this part. Negative 8a x minus 4b minus 4c raised to negative x plus 4cx e raised to negative x minus 4ax squared minus 4bx minus 4cx e raised to negative x. And then same thing here. Okay, what I mean by answering number 15, this is what you get. Okay, so calm, stay calm. We're gonna solve this. Let's just simplify like terms. Okay, that's everything for this. 3 minus 2, actually negative 6 plus 3, negative 3. Okay, that's all done. Let's just blur them. Next is this, 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 this. They actually cancel, no? Negative, positive, these cancel, these cancel. We only have a few terms left. None of them are like terms, so we just write them down. Plus 2a minus 8ax minus 4b minus 4ax squared minus 4bx equal to 8x plus 8 plus 6a raised to negative x. Okay, let's now equate the coefficients. Negative 3c equal to 6. There you go. X squared a is equal to 0. Negative 8a minus 4b is equal to 8. How about the constants? 2a minus 4b is equal to 8. Yeah, it just proves that the numbers that we found are correct. Because if we substitute what we already have, 2 times 0 minus 4 times negative 2, that amounts to positive 8. The equation is satisfied. So these are our constants. Let's substitute them back to y sub p. There you go. So 0, no? Plus, minus 2x minus 2x raised to negative x. Negative 2x, negative 2x, e raised to negative x. That is our y sub p. Let's now compile. This is the most fun part because we're almost done. Y sub c. Where is y sub c? This one. So that's our y sub c, and this is our y sub p. This is our particular solution. Let me confirm if my answer is accurate. It needs more time to check. I'll mute for a while. Okay, so yes, our answer is actually correct. The order can be different, just to let you know in advance. Everything in your y sub c, the constants are basically arbitrary. Meaning, for example, what if we rewrote it like this? C1e raised to negative 2x. And in place, C3 is negative x. It doesn't matter. It's still the same. So if you see that the answer key shows a different uh, layout, but essentially, you know that your answer is correct by the fact that you have these are basically what you have to see, no? And their corresponding constants. The notation doesn't matter. Okay? So that is the hardest, arguably, the hardest problem. Let's try something exotic. Let's try number 14. I think I'm gonna change my mind. I don't wanna make a video yet about variation of parameters. I'll think about it. My exam is in 12 hours. I still have to wake up 9 tomorrow. I mean later, because it's already 1:45 a.m. Oh my gosh. 7 hours of sleep. I can only stay for 1 hour left. Okay, let's maximize the time. Let's solve this problem. Y triple prime minus 3 double prime y double prime plus 4y. M raised to 3 minus 3m raised to 2 plus 4. Okay. Equate to 0. Okay, so how do we factor? How do we find the roots if we have this kind of equation? Let's try synthetic division. Plus minus 1. I think that's all I can think of right now. Let's try negative 1. Okay, so bring down 1 times negative 1. Sorry, it's supposed to be plus negative 4. Negative 4 times negative 1, positive 4. 8. Okay, so I don't think negative 1 is the root. How about positive 1? Okay, bring down 1. Multiply, so there you have negative 2. Wait, is my synthetic division correct? What did I do earlier? Classic mistake. Why do I not learn from my mistakes? So in synthetic division, the approach is correct. It's just that right before making whatever this is, whatever you want to call it, in this case, we only have m raised to 3, m raised to 2. We need to write a representative for m. And in that case, the most appropriate way to do that is by writing 0m and then plus 4 equal to 0. Okay, so this is technically still 0. We just wrote it there. That's really important, no, for synthetic division. You need a coefficient for every power. So m cubed, m squared, m, and then just a constant. So in that case, we need this. So 1, 3, 1, negative 3, 0, and 4. Those are all the constants we need. And then, again, let's try positive 1. Let's see if it works. Bring down 1. Multiply 1 times 1 is 1. Negative 2. Negative 2 times 1, negative 2. Negative 2, negative 2 times 1. Negative 2, 2. This has to be 0, the number over here. So 1 is not a root. Let's repeat. Bring down 1. 1 times negative 1, negative 1. Add them. Negative 3, negative 1, negative 4. Negative 4 times negative 1 is positive 4. Add 4 plus 0 is 4. 4 times negative 1 is negative 4. 4 plus negative 4 is basically 4 minus 4, which is 0. Okay? From there, these are the coefficients of your terms. This time, we started with, or like initially, we have d raised to 3, no? So now, our highest power is just going to be 2. You just deduct by 1. Can you confirm if that is correct? Ah, sorry. Wait. As simple as that. M squared minus 4m plus 4 equal to 0. Now we can factor, no? So the roots are 2 and 2. And don't forget this one. That's also a root. So there you go. Now let's form y sub c. Y sub c is c1 e raised to negative x plus c2 e raised to 2x plus c3 e raised to negative 2x. Okay, we're done there. Let's now write our r of x. R of x, 6 plus 80 cosine 2x. 6 plus, sorry. Yeah, that's correct. You now look for the roots. M is 0 for 6. Here, no. B here is 2. Alpha is 0, I think. So there's a format. Why did I specify A and alpha? Alpha and beta. When you see something like, example, number, cosine, this is the format, no? If ever you see something like this, when you look for the m or its root, its m is usually, not usually, all the time, b plus minus alpha. Sorry, the other way around. Alpha plus minus b. Yeah. So, also, you need an I, imaginary. So alpha right now is 0. You just leave it as is. And then plus minus b, and then I. So those are the roots. Let's now write y sub p. So we have a constant, just a, plus b cosine 2x. I think that will suffice as our initial guess. Does y sub c have any constant? No, it does not. So there's no conflicting terms. We can... I also forgot something else. If ever you see a transcendental like this, any of these actually, in making your initial guess of y sub p's format, you need to write out its corresponding right now we have cosine, so the other one will be sine. It's the same thing the other way around. If you have b sine 2x, it has to be accompanied with its corresponding cosine x. Okay, that's very important to know. If you leave this out, you're in big trouble. We're still early on in the solution, so try your best not to avoid any opportunity to get it right. So I think we can now differentiate b negative sine 2x negative 2b sine 2x plus 2c cosine 2x. That is the first derivative. Second, negative 2b 2 cosine 2x plus... sorry, wait. Yeah. This is not product rule. Yet. Expect to see product rule later. It's gonna be really long. Or in future problems, if it's not just here in 14. Cosine, no? Cosine to sine derivative negative. Negative 2 cosine 2x. Wait, sorry. This is supposed to be sine already. Okay, simplify before we integrate another time. Our maximum is the third derivative now. So we derive 3 times. This becomes 4b cosine 2x. Is my correction tape enough for tomorrow? Let me check if I have an extra. Yes, I do. Okay. Back to where we were. Negative 4c sine 2x yp double prime. Okay, then yp triple prime negative 4b cosine to sine negative, so this becomes positive. Derivative 2x is 2, so 2 sine 2x minus 4c, that's an ugly c, cosine, 2 cosine 2x. Simplify. 8b sine 2x minus 8c cosine 2x. Okay, that's it. Let's now form our y sub p. Sorry, no. What's our reference again? After this, you recall we have y prime triple prime minus 3y double prime plus 4y equal to 6 plus 80 cosine 2x. Give me a minute. Let's now substitute 8b sine 2x minus 8c cosine 2x. What you're hearing, I just wanted to make sure that this one at least is correct. I'm actually trying to practice also, so I'm not really supposed to look at my solutions for these problems. I've already answered this before making this video, obviously. 4y. Is it actually 4y? Ah, yes. Okay. So we don't need 4y prime right now. Okay, see if there's anything similar in the left-hand side. Sine 2x. Wait. Yeah, let's group them together. Wait. For 12c, 4c, 16c sine 2x plus 8b sine 2x. Twelve b cosine 2x, 4b cosine 2x. They are like terms. 16 minus 8c cosine 2x plus 4a is equal to that. Okay, let's start equating now. Sine 2x first. 16c plus 8b equal to 0. Okay, we can't find anything there. 16b minus 8c is equal to 80. Okay, we have two equations with the same two unknown variables. I think that's a good sign. Our lives aren't so hard at all, no? Okay, constants for a is equal to 6. A is equal to 3 over 2. Okay, so I'm not sure, even right now, if calculators are allowed in exams for this, no? Involving this lesson. Covering, rather, this lesson. Let's just do it manually, just to play it safe. Okay, so b is equal to negative 2 times negative 2. B is equal to 4. Recall over y sub p. It's equal to what? This. Okay, add them together. Just check if I got it right. Okay. 3/2. Yep, we got it right. Okay, so we solved 3 problems on MUC. Doesn't feel right not having enough time to recall everything. It's already 2 p.m. 2 a.m. rather. I think I'll end the video here. I wish I could answer more, but that's basically it. That's almost all, if not all, of the essentials whenever you try to solve MUC. I'm realizing right now, these kinds of questions are pretty simple, actually. It's just uh, yeah, they're very much simple. Actually, let's try solving a few problems on VOP. So I still have a little more energy in me. I'll target answering a few, maybe 3 problems too. 1 to 3 problems. Let's have this. So d raised to 3 plus d y is equal to secant x. So you know that you have to use variation of parameters method if you see this kind of problem, because your right hand side is a transcendental function that isn't sine or cosine. So that will already tell you use VOP, because strictly MUC, what we have been doing, will not work. So yeah, let's do it. So same thing. The approaches are very similar. It's only the integration part that's different, that makes VOP different. So okay, y triple prime plus y prime is equal to secant x. M raised to 3 plus m is equal to secant x. Sorry, equated to 0 already. Okay, we have this. M is equal to 0 and m squared is equal to -1 square root. So we have negative, this is going to be plus minus imaginary number. If ever, let's say this was 2, the plus minus 2i. But right now it's just 1, so just I. I hope you can see the logic in that. So, okay. Y sub c, let's make it C1e raised to 0x plus C2e. So if you see imaginary, this calls for transcendental. So C2 cosine. Okay, identify what your b is here. Again, the format is alpha plus minus b, I. Right? So b here is just 1. Alpha is 0. So 0 plus minus doesn't change anything. So alpha is 0. Again, your transcendentals are cosine and sine. Bx, bx. And under these expressions, the assumption is that your alpha is equal to 0. No? So, okay. So b is just 1. So cosine x plus c3 sine x. So that is your yc. Let us now write, actually we can simplify this. E raised to 0x is just c1, just a constant. So later, if you're gonna, not if, when you are about to write your y sub p, you're gonna make a guess. Avoid constants. It's gonna conflict already. Okay? So that is for your yc. Let's now move on to y sub p. Y sub p, this is a problem on variation of parameters. So this is where the part is different. Usually, right, we look for our r of x from the right hand side. Right now, there is no r of x. You look for y sub b from here. You're basically gonna replace the c1, c2, c3 as a, b, and c. So c1 is a, c2 is b, then copy the rest. c3 is c, and then sine x. Okay? And then this is the part where you derive. So a prime. This is the part where a, b, and c are considered not constants, no? In MUC, these ABCs are constants. Here, we treat them as variables. So the derivative of a is a prime. Okay? So b prime cosine x plus b sine x minus plus c sine x, c prime rather, plus c cosine x. Okay? And then y double prime is equal to a we are still deriving. Let me read my notes. I forgot what to do. This is exactly the reason why review is very important. Sorry. I just did this a while ago. I mean, not exactly this question, but the process is the same. At this point, you let everything that is prime here, so a prime, b prime cosine x, and c prime sine x, equate them all to 0. So what you have left for y prime is just negative b sine x plus c cosine x. Y double prime is equal to Okay, so that's when you start integrating. Differentiating the second time. We're gonna make what we let as equation 1. No? This one. That is very specific. You have to know that. Negative b prime sine x plus b cosine x plus third power. Okay. C prime cosine x plus c sine x. This becomes minus. Simplify. Okay, third derivative. Third derivative. That means for the second time, we let everything that's prime equal to 0. So what we're left with are these. Now we find the third derivative. Okay, so after this, recall, this is what you're initially given. Let's now substitute. Just to make our solving faster, I'll just copy paste. Our y prime is this one. And then equal to secant x. Okay, so instead of equating the coefficients, that's only in MUC. Here, what you do is well, right now you can still simplify this. Let's do that first. So these will cancel, no? There you go. So it's much more clearer what I have to do. We don't equate the coefficients anymore. We have we have variables. B and C are prime, no? We have 3 missing values. This is third power, so we have to look for A, B, and C. If we only reach up to second power, we only usually look for A and B. So we need to look for 3 equations. What's our first equation is this one. No? The second equation is the second time we let the prime values equal to 0. So that's equation 2. Equation 3 is this one. Let's combine them together. This is equation 1. This is equation 2. This is equation 3. Okay, so where do we start? It's actually pretty simple. Let's focus on these 2 equations first. We can choose elimination method, no? Sine x cosine x. So what we get is b prime sine squared x plus c prime cosine x sine x equal to 0. Negative b prime cosine x squared minus c prime cosine x sine x equal to secant x is 1 over cosine x. So when we multiply it by cosine x, we just get 1. So add everything. What you get is b prime sine squared x minus b prime cosine squared x. These cancel. That's exactly the point for elimination, no? You can filter the negative sign, bring it to the other side. This becomes plus, this becomes minus. B prime is sine squared x plus cosine squared x. That's basically just 1. So b prime is negative 1. And then you integrate. The integral of b prime is equal to negative x, no? So that's how you integrate. And then, okay, we already know what b prime is. It's negative 1. Substitute it back. So negative b, let's use this equation to substitute back. Negative 1 cosine x minus c prime sine x equal to secant x. This is tricky. Cosine over sine is cotangent x. Good luck with this because we have to actually integrate this later on. So if ever it gets complicated, try to, because again, I chose this equation, no? The more complicated equation. There's another way. I just didn't choose it for experimental purposes. We can use this equation. Any would do. Just see what's more simple. So negative 1 is our, wait a minute. Either way, this is supposed to be positive. Let's see if we get the same. Negative b prime is negative 1. You're supposed to look here. Negative sine x. There you go. It's much simpler. So, integrate. You have to remember your identities. So what is the integral of tangent? That is ln tan x plus secant x. Oh no, sorry. Reserved for secant, cosecant. Tangent is, I think secant x. Oh wait, sorry. Earlier, we integrated, no? Don't forget the constant of integration. Here it's c sub b. Here it's c sub c. I think that's the one. What is the integral of tangent? It's actually wrong. Tangent cosine. Actually, no. Yeah, I got it right. ln secant x. Only the reason why we have a negative here is because of this. Integral of tan x is literally this one. Another render of it is negative ln cosine of x, which I hope would have been what I remembered, because it's easier to remember. Integral of cotangent x, on the other hand, is supposed to be ln cosecant x. Sorry, sine rather. Sine and cosine, cotangent to tangent. Yeah, I just have to remember tangent, sine over cosine. Cosine is its foot. Same thing here. For cotangent, it's cosine over sine. Sine is the foot. Okay. Okay. Let's stick with this one. Plus. Yeah. ln cosine x plus c. What else? A. So we already know B and C. That's the only way to find A. Minus x cosine x plus ln cosine x. So this is how we do it now. Substitute, and then at the end, after we're done substituting everything, that's when we write down the constants. So we have C. Oh wait, sorry. That's for later. Right now we just substituted. Supposedly B prime and C prime, not the B and C. Where is our B and C? C prime is this. B prime is this. Okay. Again, B prime is negative 1. Or just negative cosine x. And then plus negative tangent x times sine x equal to 0. It's this one, no? Okay. Simplify. Sine over cosine. Sine. Wait. I don't wanna write it fast. Sine squared x over cosine x. If you put cosine here, this becomes squared. Put them together. Okay. 1 over cosine x. Beautiful. A prime is equal to secant x. Okay, integrate now. secant x, secant and cosecant, no? ln secant x plus tangent x plus c sub a. Okay, so that's your a. Yeah. And just to let you know also, if we have cosecant x dx, that is negative ln cosecant x plus cotangent x. Then don't forget the constant of integration. Yeah, okay, I remember it correctly. Okay, so a, b, and c. We already have a, b, and c. Let's now substitute in the yp. So a is what? So that's our a. How about our b? Minus x, no? And then our c, ln cosine x. And this is the only time when we start putting the constants together. CA, CB, CC. This eventually becomes C sub 3. It's just any notation. Doesn't really matter. Yeah. You can choose any notation for the constant of integration. But essentially, your y sub b is just this. It's already this. Let's compile now. Y sub c plus y sub p. What is our y sub c? This one. That's our y sub c, and our y sub p is this one. Okay. That is our particular solution. Wait. We can simplify this further. So what else are constants? C1 and C3 are constants, no? Sorry. Okay. We can actually simplify that further. So we have left C2 cosine x plus C3 sine x plus wait a minute. Sorry. Lazy work. So A prime, that's correct. We just add it exactly. For B, cosine x. B is negative x. You have to put cosine x. And then plus C. C is this one. And then sine x, no? Okay. We fixed it. Let's fix this. Bruh. These are like terms. And then just copy the rest. And then plus C sub 4. Okay. So this is the particular solution. so as you might have noticed, it took longer, no, to solve this problem. This is variation of parameters. You had to use integration because you saw in the problem, this is secant x. It's a transcendental function that is not cosine or sine. So that already tells you use VOP. As simple as that. There's another way to solve. You can make use of the Ronscan method. Although I don't think it can help, but like I don't really know much about it yet. This is what I've been used to for the past few days of studying it. So this is how I do it. For the run scan method, it's just matrices. You should, sorry. Basically, you would look for A prime, B prime, and yeah, you're not accepted from the integration part. You still have to do the integration. But that's another way of finding A prime and B prime, or even C prime if you have C prime. If the power of your given is maximum 3. Okay. So I think run scan is better, no? If we have too many equations. Actually, no. I think it's a substitute for solving by systems of linear equations. But essentially, you need to go through these equations first. That's the only time you get to form the matrices. Okay, so yeah, just pick a struggle. Okay, I'll end the video now. I'm so tired.